This is an introduction to structural geology, which generally considers the orientation of rock units. And by orientation we mean, are the rock units horizontal, like layers in a cake? Are they vertical, like a book standing on a bookshelf? Or are they sloping, somewhere in between, such as shown as in this figure? In order to talk about the orientation of rock units, we have to be able to quantify it and put numbers on it. And we use a concept called strike and dip to do this, and this is illustrated in the chapter on structural geology. There are several ways to discuss strike and dip, and I suggest that you study this diagram carefully to get an understanding for what each one of these stands for. This information is conveyed in both compass directions and angles, as shown in the strike and the dip angle. The slope of this rock unit is about 30 degrees with respect to a horizontal plane. This is described in the caption, and then this information is reduced to a map symbol, which is shown in this figure. So be sure you have a look at this page in your lab manual. When we look at topographic maps and ortho images, as you're going to be doing in this lab, oftentimes we get visual clues of the orientation of the rock units. In this block diagram, we can see some rock layers that are rather steeply dipping, and when they outcrop at the surface, they're eroded in such a way that we get some information about the direction and their angle of dip. And several terms are used in this introductory exercises that are defined here. For example, flat iron, hogback, and cuesta. Here's a flat iron. You're going to be asked to take notice of several flat irons in this introductory exercise. Notice that when a stream cuts through or erodes these flat irons, it forms a notch. We're going to call this a V, and this V gives us some crucial information. In this case, the V will point in the same direction that the beds are dipping. And this leads us to a consideration of the last topic on this page, which is the rule of V's. The rule of V's allows us to interpret the direction that the rock layers might be dipping underground. Several examples are shown in this diagram at the bottom of the page, and I want to speak about each one of them briefly. If the beds are dipping at 90 degrees, in other words, they're vertical, such as a book on a bookshelf would be, when a stream erodes across those layers, no V is formed. The rock units show no deflection on either side of the stream. However, if we tilt those beds either way, when the stream erodes through them, a V notch is formed. This is the same V notch that we were seeing in, between the flat irons in the previous diagram. The direction that the V points indicates which way the beds are dipping, or agrees with the direction of dip. So in this case, these beds are dipping to the right of the page. The V points to the right. In this case, the beds are dipping to the left of the page, and the beds are dipping to the left. In the third scenario, when beds have a 0 degree dip, or they're horizontal like layers on a cake, there will be no V formed, or at least the V's that are formed will point in random directions, all directions. They're parallel with the contour lines in this case. You remember from a previous lab that the contour lines represent points of equal elevation, and that's exactly what we see in horizontal beds. If a bed is horizontal, it's at the same elevation everywhere. So the V's are parallel to the contour lines in this case. So again, study this page carefully as you prepare for the first activity in this exercise. Another thing that you'll want to take a look at in preparation for this exercise is the map symbol, the legend, commonly used symbols on geologic maps. There's the strike dip symbol that we've already mentioned before. A special symbol when beds are vertical. Another special symbol when beds are horizontal. And then additional information on this legend is found at the bottom, where abbreviations for the ages of rock units are listed. This legend is a bit confusing in that there are 3 columns here, and I'm going to indicate which one is the oldest. These Precambrian units are the oldest. I'll indicate that with a 1. Cambrian is next, Ordovician, Silurian, Devonian. And then next comes Mississippian at 6, 7, 8, 9, Jurassic. And then Cretaceous is just younger than Jurassic. So relative ages of the beds, we're going to see that becomes an important way to tell the orientation of rock layers as well, their ages. So use this legend as you work on this exercise. Finally, I would like to point out additional pages where geologic structures are shown in both a map view and in what we're going to call a block diagram. The map view of this structure indicates the same bed outcropping in 2 different places. The strike dip symbols are pointing towards one another, or the dip symbols are pointing towards one another, and this is the interpretation of what's going on in the cross section. I should also let you know that this symbol is incorrect. This is an error in the textbook. That particular fold symbol is incorrect. On the other hand, though, this one is correct. Dip symbols are pointing away from each other, so this bed is dipping to the east, this bed is dipping to the west, and that's reflected in the cross section that's drawn underneath. These 2 folds have names, of course. This is called a syncline, this is called an anticline. That fold, both of those folds shown in slightly more complex form, what we call a plunging syncline and a plunging anticline, when the axes of those folds are tilted. And then finally, a variation on the anticline and syncline that we call a dome and a basin. Map view, notice that the dip symbols are all pointing away from the center. In this model, all the dip symbols are pointing towards the center, defining the basin. Take a look at how the artist has represented this hogback ridge. You can see that there's streams flowing across it. And where a stream flows across the ridge, a V notch is formed, and the V points in the direction that the beds are dipping, away from the center. Now on to the first activity, where you're asked to complete these diagrams. You're going to be completing these diagrams and mailing them into your instructor. To complete them, you'll put the appropriate symbol on these beds using the legend. This refers you back to figure 10.1. So a few pages earlier in the text, have a look at that figure and then try to place the correct map symbol on each one of these units. The second part of this exercise shows you some layers that are outcropping at the surface in 2 different diagrams and a stream crossing those layers. And we're asking you to interpret what's going on in the subsurface, a cross section you'll draw in this rectangle below the diagram based on the rule of V's and the stream crossing. And then finally, an ortho image that shows flat irons. You remember the flat iron is a wedge-shaped outcrop of rock that's created by erosion as streams flow across. In this case, here's the stream. Here's another stream. The flat irons are in between. There's one, there's another. And here are the V notches eroded by the stream as it crosses. So using your rule of V, we want you to indicate which direction the beds are dipping and what the strike is, and then draw a strike dip symbol on that diagram. Now I'd like to complete just a couple of these for you on some sample blocks. These blocks are not in your textbook, so you won't find them in your materials, but hopefully this exercise will help you understand how to complete some of these diagrams. We've got a map view of some rock layers outcropping at the surface, accompanied by strike dip symbols. And so this map view represents the top of this block as if we were looking directly down on it from above. Notice the orientation of these strike dip symbols is slightly different because of a perspective view. We're looking at this block from above and to the side, and so that causes the strike dip symbols to be drawn slightly differently there. Now, the strike dip symbol tells us that these beds are dipping at 30 degrees, in this case to the east. And so I'm going to approximate a 30-degree angle right here. I'm just estimating, visually estimating a 30-degree angle. This one says the same thing, so I assume that all beds in between are dipping at the same angle. And I would complete the front of the block that way, and the sides of the block would follow. This is the cross section. Let's take a look at the next one. Map view. Information tells us that these beds are dipping at 45 degrees to the north. Not all of them are drawn in on this block. We're going to have to complete those. So I'm going to place this contact at this location on the block. This contact I estimate to be right about here. And then the final contact there. I'll put the strike dip symbol on this bed. Again, notice that in the perspective view, the strike dip symbol looks slightly different than it does in the map view. Now, in order to make these beds dip 45 degrees to the north, I would draw them in like this. Okay, so I hope that gives you a general idea of how to complete the cross section in the introductory exercise. Now let's go and look at the second part of this activity, which uses more ortho images. Faults are introduced in this one, and I hope that you can see where certain layers are offset by a fault. We're looking again down on the surface of the earth, which has very little vegetation on it, so we can see rock layers represented by different colors. And these rock layers are discontinuous, that is, they have a break in them. This one is the most obvious one. So we'd like for you to draw the fault directly on this photograph, which separates rock layers from one another where they are no longer continuous. The last part of this exercise again involves rules of V's, and we would like for you to place strike dip symbols. Again, here are the rock layers, there's a stream. So the rock layers are forming a V where that stream crosses them, and that's going to give you some information about their direction of dip. Here more streams, more V's. All right, I hope this little introduction to structural geology and strike and dip will help you complete the first activity in this lab.